Today I start the unit number 2, BJT. So BJT means bipolar junction transistor, presented by Dr. K. SRINIVASULU from St. Peter's Engineering College. So BJT full form is B for bipolar, J for junction, T for transistor. So bipolar under two directions. Okay. Introduction of the BJT. The transistor is a three-layer semiconductor device consisting of either two N and one P-type layers of material or two P and one N-type layers of material. This form is called an NPN transistor, while the latter is called a PNP transistor. So there are two types of BJT. One is PNP transistor, second one is NPN transistor. So here, what is the PNP transistor? PNP. So two P layers, one N layer. Sandwich between P layers is called PNP transistor. NPN transistor means two N transistors, one P transistor. So P layer is sandwiched between two N layers. Is called the NPN transistor. Okay. So here bipolar junction transistor, this is the symbol of the NPN transistor. Next one, PNP transistor construction. In each transistor, following points to be noted. There are two junctions. So transistor can be considered as two diode connected back to back. So there are three terminals. The middle section is the thin than other. Transistor terminal names. Transistor has three sections of doped semiconductor. The section one side is called the emitter and the opposite side is called the collector. The middle section is called the base. So doping means here impurities are adding. Please, doping means impurities. Impurities means boron, phosphor, silicon, like that. These are all called impurities. So these impurities are added to the emitter, collector, base. Okay, so this is the transistor symbol. Every transistor consisting of three terminals, first emitter, base, collector. Okay, so every transistor, either NPN transistor or PNP transistor, whatever may be, each transistor consisting of three terminals. First one is a emitter, second one is a base, third one is a collector. So that is the symbol of the transistor. Okay, next. So emitter, what is the function of the emitter? Okay, so the section of one side that supplies carriers is called emitter. Emitter is always forward biased with respect to base. It can supply carrier. For NPN transistor, emitter supply volts to its junction. For PNP transistor, emitter supply electrons to its junction. So this is the function of the emitter. Next one, collector. So the section on the other side that collects carrier is called the collector. The collector is always reverse bias with respect to base. For NPN transistor, the collector receives volts to its junction. For PNP transistor, collector receives electrons to its junction. Okay, so collector function means to collect the minority carriers. Okay, what is the base? So the middle section which forms two PN junction between emitter and collector is called the base. So please, base is common for the emitter and base. Base is middle section of the transistor, either PNP transistor or NPN transistor, whatever may be. So base is a middle section of the transistor. Okay. Next. Some factors to be remembered. The transistor has three regions named emitter, base and collector. The base is much thinner than the other region. Emitter is heavily doped So it can inject large amount of carriers into the base. So here heavily doped means you are added more you are added the more impurities to the emitter. So that is a heavily doped. So this is the emitter is a powerful, very strong comparing the base and collector. Why? Because it is a heavily doped. Heavily doped. Doped means adding the impurities. So base is lightly doped, so it can pass most of the carrier to the collector. Collector is moderately doped. Heavily doped, lightly doped, moderately doped. So emitter is a heavily doped. Base is a lightly doped. Collector is moderately doped. So depending on the doping, depending on the impurities are adding, the functions, the elements working. So emitter is heavily doped, that is very strong. Base is lightly doped. Collector is moderately doped. That means low impurities are added. So this junction between the emitter and base is called the emitter-base junction. Emitter-base junction. So the junction between the emitter and base is called the emitter-base junction. That is the emitter diode. And the junction between the base and collector is called the collector-base junction. That is the collector diode. So here, so junction means the between the terminals. So between the emitter and base is called the emitter-base junction. So the between the collector and the base is called the collector junction. Okay. So the emitter diode is always forward biased, and collector diode is a reverse biased. Please to remember emitter diode. So emitter diode means emitter and base. That means input is always forward bias, output is a reverse bias. That means collector to base. So here the resistance of the emitter diode is very small in case of forward bias, and resistance of collector diode is high in case of reverse bias. Please to remember. So emitter junction is forward bias. That means the resistance is also very small. So then only the current is passing in forward bias. But in case of collector diode, so that is reverse bias. That is resistance is very high. So that no current is passing. That is called the reverse bias. So reverse bias is occur at a collector diode. So transistor operation. Here two types of transistors are there. One is NPN transistor, second one is a PNP transistor. So how to work in the NPN transistor? So this is the circuit diagram of the NPN transistor. So NPN. So two N layers, one P layer. So the P layer sandwiched between two N layers is called the NPN transistor. That is the definition of the NPN transistor. What is the NPN transistor? P layer sandwich between two N layers is called the NPN transistor. Okay, so here emitter, base and collector. So here two power supplies there, VEB, emitter, base voltage, VCB, collector to base voltage. So high emitter current, IC collector current, IB means base current. So forward bias is applied to the emitter base junction and reverse bias is applied to the collector base junction. So this is the initial arrangement of the any transistor. Once you are arranging like that, input is become a forward bias, output become a reverse bias. So that's why transistor also is called the switch. Transistor is also switch. So forward bias in the emitter base junction causes electrons to move toward the base. This constitutes emitter current I. So the forward bias in the emitter base junction causes electrons to move toward the base. So from emitter to base, the electrons moves. So that's why this constitutes emitter current is I. Emitter terminal is consisting of the current is IE. So that will be that can be represented with the letter I suffix E. E for emitter, I for current. So that's what is called emitter current, IE. Okay. Next, as these electrons flow toward the p-type base, they try to recombine with holes. As base is lightly doped, only few electrons recombine with holes within the base. So this recombined electrons constitute small. base current. The remainder electrons crosses base and constitute collector current. So that is I equal to IB plus IC. That means emitter current is equal to base current plus collector current. So emitter current is equal to base current plus collector current. That is the I equal to IB plus IC. So next, working of PNP transistor. So this is also, what is the PNP transistor? Two P layers, one N layer. So the N layer sandwich between two P layers is called the PNP transistor. Here also three terminals are there. One is emitter, one is a base, another one is a collector. IE means emitter current, IB means base current, IC means collector current. Here also VEB, V suffix EB, that means emitter base voltage. VCB, collector base voltage. Okay. So here for forward bias is applied to the emitter base junction and reverse bias is applied to collector base junction. So this is the minimum requirement for working of the any transistor. Once you are arranging like that, our diode, our transistor is ready to work. Okay, the forward bias in the emitter base junction causes holes to move toward the base. So in NPN transistor, the electrons moves to the base. But in case of PNP transistor, holes to move towards the base. Okay, so this constituted emitter current is IE. As these holes flow toward N-type base, they try to recombine with the electrons. As base is lightly doped, only few holes recombine with electrons within the base. So these recombined holes constitute small base current. The remainder holes crosses base and constitute collector current. So here transistor symbols, one is NPN transistor, second one PNP transistor. So NPN transistor, either PNP transistor, any consisting of three terminals. So one is a emitter, base and collector. So that is the construction. So below that one is a symbol of the NPN transistor. So next one PNP transistor. That is the construction of PNP transistor. Below diagram is the symbol of the PNP transistor. So please, to very important, draw the symbol of the NPN transistor, draw the symbol of the PNP transistor. So the arrow mark is very important. So if you forget the arrow mark, so automatically very difficult to find the either the NPN transistor or PNP transistor. NPN transistor, so NPN transistor, in case of NPN transistor, arrow mark is a upward. In PNP transistor, arrow mark is downward. Okay. Thank you for all for watching this video.